Okay, in this lecture, I am going to solve numericals on interference of the light. The first numerical is written over here. A soap film of 5 into 10 to power minus 5 centimeter thick is viewed at an angle of 35 degree to the normal. Find wavelength in the visible spectrum, which will be absent from the reflected light. So first let us write what is given. Quantities. The thickness of the film is given. First, the soap film is given. So, you know that soap film is parallel thin film. This is parallel thin film. Then thickness of that film is given T, which is here 5 into 10 to the power minus 5 centimeter. Then this film is viewed at an angle of 35 degree to the normal. It means angle of incidence is given, I is given, that is 35 degree. Now the mu refractive index is not mentioned here, but since this is a soap film, it's a water, so we have to take mu equals to 1.33. Refractive index of water is 1.33. And what we have to find is wavelengths. Wavelengths in visible spectrum which are absent in reflected light. So this is nothing but interference in the reflected light, and the wavelengths are absent in the reflected light means that waves are interfering destructively. So we have to consider that condition for the destructive interference. So let us write the formula for this. Angle of incidence is given. What we require, what is needed is angle of refraction that we can find using Snell's law, which is mu equals to sine I by sine R. But we have to find sine R. So sine R is equals to sine I by mu. And the second formula is, we know the condition for destructive interference in the reflected light is 2 mu t cos R is equals to n lambda. This is a condition for destructive interference. In reflected light, because the interference takes place in the reflected light, and that is a destructive interference. So these two formulas we're going to use, and let's go to the solution. You need to solve the problem systematically, then only you get the full marks. Now here first we will find the R. So we know that sine R is equals to sine I upon mu, that is sine of I is given 35 degree divided by mu, which is 1.33, and sine of 35 degree is 0.574 divided by 1.33. So we get Sin r. After solving this, we get sin r is equals to 0.4313. We have to find r, so r equals to sin inverse of 0.4313, and that comes around 25.55 degree. In the formula, what is required is cos r. So let us find the value of cos r also here. That is cos of 25.55 degree, and it is equals to 0.902. So we got the value of cos r. Then let us find absent wavelengths in the visible spectra in the reflected light. There could be the number of wavelengths. We have to find that by changing the order. So we have here for destructive interference 2 mu t cos r is equals to n lambda. What we have to find is lambda. So lambda is 2 mu t cos r upon n. Let us go on changing the values of n and find the wavelengths. So the first, we will take n equals to 1. N equals to 1, lambda is lambda 1. Then 2 into mu is 1.33 into t, thickness is given 5 into 10 raised to minus 5 centimeter. 5 into 10 to the power minus 5 centimeter into cos r. Value of cos r is 0.902, and that divided by n, which is 1 in this case. After solving this, you get 11.999 into 10 to power minus 5 centimeter, which is 12 into 10 to the power minus 5 centimeter, and that is equals to 12,000 angstrom. But this wavelength is not in the visible spectrum. This is in infrared region. So we have to forget about this. Then let us take n equals to 2. So lambda 2 is equals to so UD time we're going to use this 2 mu t cos r. So let us find the value of this 2 mu t cos r, and that is, I will write over here, 2 into 1.33 into 0.902 into 5 equals to. So this is 11.997 into 10 to the power minus 5. And that divided by 1. So while finding the value of lambda, this 2 mu t cos r is a constant, and that value is 11.997 into 10 raised to minus 5, and this divided by n, and n is equals to 2. So 11.997 divided by 2, we get 999 into 10 to the power minus 5. So that is nothing, that is equals to, we can round up, 6 into 10 to the power minus 5 centimeter, and that is equals to 6000 angstrom. And this wavelength is of course in the visible spectrum. So this wavelength will be absent in the reflected light. We are studying the destructive interference here. Then let's find what we get when n equals to 3. When n equals to 3, say lambda 3 is equals to same thing, 11.997 into 10 to the power minus 5, and that divided by 3. And this value is close to 4 into 10 to the power minus 5 centimeter. And that is nothing but 4000 angstrom. So this wavelength is also in the from the visible spectrum. So this wavelength will be absent in the reflected light. Then let us see if there is further any wavelengths absent in the reflected light. We will see the when n equals to 4, and the lambda 4 in that case is 11.997 into 10 to the power minus 5 divided by 4. So it is just like, the 12 divided by 4, which is 3 into 10 raised to minus 5 centimeter. And that is nothing but 3000 angstrom. And this 3000 angstrom wavelength is not in the visible spectrum. This is in ultraviolet region. So we got only the two waves. If you take n equals to 5, then we will go in again in the ultraviolet region only. So we will stop here, and we got absent wavelengths in the reflected light. Absent wavelengths in reflected light. In visible spectrum. We want to find only in the visible spectrums, and they are 6000 angstrom and 4000 angstrom, and this is the answer. Then let us go to the second sum. Let us read it. A drop of oil 0.2 cc. 0.2 cc means 0.2 centimeter cube. That is the volume of that drop. Is spread uniformly on a water surface of 1 meter square. So when it uniformly spread on water surface, it forms a film of equal thickness. So let us write first what is given here while reading the sum. Given is volume of the drop 0.2 centimeter cube. Instead of writing cc, I am writing 0.2 centimeter cube, which spreads on area, spreads uniformly. Okay, it spreads uniformly on area of 1 meter square. Area is 1 meter square. 1 meter square is nothing but 100 into 100 centimeter square. We are considering only in centimeter square. CGS system. Then the white light, which is incident normally, is observed through the spectrometer. Now there is a normal incidence here. For normal incidence, R equals to 0. I is also 0. And therefore, cos R is equals to 1. Whose center has wavelength 5.86 into 10 raised to minus 5 centimeter. So wavelength is given. Wavelength lambda is equals to 5.86 into 10 to the power minus 5 centimeter. And that is in the air, so mu equals to 1 for air. And what is asked is find refractive index of the oil. Sorry, not mu is not 1. The film is oil film. So we have to find mu equals to what? So that is given. Then the formula is, it is a dark band, and that is in the reflected light. So this is destructive interference. So for destructive interference, the condition for destructive interference in the reflected light is 2 mu t cos r is equals to n lambda. And what you have to find is mu. So mu equals to n lambda upon 2t cos r. But we don't know t. So we have to find the thickness first. So thickness is volume by area. So 0.2 centimeter cube volume of drop spreads uniformly on the area of the water surface, which is 100 into 100 centimeters square. So this you get around, say, 2 into 10 to the power minus 5 centimeter. Okay, so this is the thickness. Thickness is volume upon area. So we got the thickness. So let us find mu. Mu equals to n lambda. If n is not given, you have to take n equals to 1. Let us take n equals to 1. So 1 into lambda. Lambda is 5.86 into 10 to the power minus 5. 5.86 into 10 to the power minus 5 divided by 2 into thickness. This is the thickness we got. 2 into 10 raised to minus 5 centimeter into cos r. R is 0, so cos r is 1. And after simplification this, what we get is 1.465. So refractive index of the oil is 1.465. That is the answer. Let us go to the next sum. Again, there is a soap film of refractive index 4/3. So let's start writing what is given. Given refractive index 4/3. It's a soap film, so water, and it is 1 point, and this is nothing but 1.33. And of thickness 1.5 into 10 to the power minus 4 centimeters. So thickness of the film is also given, and that is 1.5 into 10 raised to minus 4 centimeter. Is illuminated by white light incident at an angle of 45 degree. So angle of incidence is given, I is equals to 45 degree. So we have to find angle of refraction first. Then light reflected by it is examined by a spectrometer in which a dark band is found corresponding of wavelength 5.5 into 10 to power minus 5 centimeter. So wavelength is given 5.5 into 10 to power minus 5 centimeter, and it is a destructive interference in the reflected light. And what is asked is calculate order of interference of band. So we have to find order n. So initially angle of incidence is given. So first we have to find angle of refraction. For that we're gonna use sin r is equals to sin I by mu to get the r, and then destructive conditions in the reflected light is 2 mu t cos r is equals to n lambda. So these two formulas we're gonna use. Then let's go to the solution. So let us first find angle of refraction. So sin r equals to sine of 45 degree divided by refractive index, which is 1.33, and sine of 45 is 0.707, 0.707 divided by 1.33, and that is 0.53. This is equals to 0.53. So R equals to sine inverse of 0.53, and that is equals to 32 degree. So R equals to 32 degree. Therefore cos R, that is cos of 32 degree, is equals to 0.848. 848. So we got the cos R here. Then we have to use this condition to find the n. So from that equation, we can write n is equals to 2 mu t cos r divided by lambda. So 2 mu is 1.33, thickness is given. Thickness is 5.5 into 10 raised to minus 5 or minus 4. It is a, sorry, it is 1.5 into 10 to power minus 4. 1.5 into 10 raised to minus 4 into cos r, which is 0.848, and divided by wavelength. Wavelength is 5.5 into 10 to the power minus 5 centimeter. So after solving it, we get n equals to 6.17, which is close to the 6. Order cannot be 6.17. It should be the natural number. N is the natural number here. So instead of 6.17, which is close to the 6, so we will take it as a 6. So we got the order 6. Okay, then let's go to the another sum. It's written over here. Same problem is there on the soap film only. That is a parallel thin film. Let's see what is the given. White light is incident on a soap film at an angle 53 degree, and reflected light is observed with the spectrometer. So again, there is an interference in the reflected light. The angle of incidence is given. So let us write what are the given terms. So angle of incidence is 53 degree, and it is interference in the reflected light. Then it is found that two consecutive dark bands, now there are two bands, corresponds to wavelength 6 into 10 to power minus 5 centimeter and 5.8 into 10 to the power minus 5 centimeter overlaps. Okay, they overlaps. So two wavelengths are given here, lambda 1 and lambda 2. So let us write two wavelengths. Lambda 1 is 6 into 10 to the power minus 5 centimeter. Lambda 2 is also given, 5.8 into 10 to the power minus 5 centimeters. And the bands, the dark bands which are formed due to these two wavelengths, they are overlapping. If refractive index of film is 1.45, so mu is given 1.45. Calculate film thickness. We have to calculate thickness. So here it is written two consecutive dark bands corresponding to wavelength lambda 1 and lambda 2. So let us take n and n plus 1. These are the two consecutive bands. Due to wavelengths lambda 1 and lambda 2 respectively overlaps. Okay, these two bands overlaps. The dark bands overlaps. So let us write the equation for the destructive interference. For n dark band, nth dark band, this dark band is corresponding to wavelength lambda 1. So we can write 2 mu t cos r is equals to n lambda 1. And n plus 1 dark band corresponding to wavelength lambda 2. So this is 2 mu t cos r is equals to n plus 1 lambda 2. This is say equation 1, equation 2. Now these bands overlaps. So therefore we can write then, see this left hand side same. So we can equate their right hand side. Left hand side is same because they are overlapping. So n lambda 1 is equals to n plus 1 lambda 2. Simplify. Take n lambda 2 to the LHS side. Lambda 1 minus lambda 2 is equals to lambda 2. and therefore n is equals to lambda 2 upon lambda 1 minus lambda 2. So using these equations, we can find the order. This is nothing but order. Lambda 2 upon lambda 1 minus lambda 2. And what is asked is, let us see what is asked. Calculate the film thickness. So you can consider any equation 1 or equation 2 to find the thickness. So let us consider the equation 1. 2 mu t cos r is equals to n lambda 1. But this n is equals to this. N is this. So we can write lambda 2 into lambda 1 upon lambda 1 minus lambda 2. That is 2 mu t cos of r. What we have to find is the thickness. So thickness is equals to lambda 2 lambda 1 minus lambda 2 in the bracket, and this is 2 mu cos r. Okay, so this is the equation for t. But here we don't know the t. We don't know t and we have to find the t, but we don't know cos r. Angle of incidence is given. So we have to use this formula also. Sin r equals to sin I upon mu. And the I is 53 and mu is 1.45. So sine of 53 degree divided by 1.45. And sine of 45 is sine of 45, not sine of 45, sine of 53 is, this is equals to 0.7986 divided by 1.45. And that comes around 0.55. This is equals to 0.55. So sin r equals to 0.55. So r equals to sine inverse of 0.55. And sine inverse of 0.55 is 33.37 degree. And so the cos r, that is cos of 33.37, is equals to 0.835. So this is the value of our cos r. Now let us find the t. So t is equals to lambda 2 into lambda 1. Lambda 1 into lambda 2, that is 6 into 10 to the power minus 5 centimeter is lambda 1. Lambda 2 is 5.8 into 10 raised to minus 5 centimeter divided by lambda 1 minus lambda 2, that is 6 minus 5.8 into 10 to the power minus 5 centimeter into 2 mu cos r. So 2 mu is 1.45, cos r is 0.835. and this comes around 71.85 into 10 to the power minus 5 centimeter. Nice way to write is 7.185 into 10 to the power minus 4 centimeter. So that is the thickness of the film. Then let's go to the next sum. This sum is on the wedge-shaped air film, sum number 5, and this is on the wedge-shaped air film. A glass of wedge angle 0.01 radian. So let us write given terms. Wedge angle is 0.01 radian. See, it is extremely small. And this is illuminated by monochromatic light of wavelength 6000 angstrom. So wavelength is given 6000 angstrom, nothing but 6 into 10 to the power minus 5 centimeter. Falling normally on it. So there is a normal incidence, so R equals to 0, and therefore cos R is equals to 1. At what distance from edge of wedge 10th dark fringe will be observed in the reflected light? So we have to find at what distance you will see the 10th dark fringe. So n is given. N is 10. Now we know that for the dark fringe, we have the condition, that is a formula for the destructive interference in the reflected light. 2 mu t cos of R plus alpha is equals to n lambda. Okay, this is for destructive interference. In reflected light. We studied only reflected light for the wedge-shaped film. So this is our formula. In this formula, mu is 1. It is air film. Okay, nothing mentioned about the mu, so let us take mu equals to 1 for air film. Let us say that that film is air. So mu is equals to 1. There is a normal incidence, R equals to 0. Alpha is extremely small. So let us take that equals to 0. Then this equation becomes 2t equals to n lambda. Cos R plus alpha would be 1, mu is 1. So we get 2t is equals to n lambda. Let us say this is our equation 1. See, what is said that this is the wedge-shaped film. And here you see the fringe. Let us say the thickness of that fringe is t. And the length of that film is L. And this is the alpha. Now you know that from this equation we can write alpha is equals to T upon L. Because alpha is small, this is nothing but the tan alpha, but alpha is small, and so tan alpha is equals to alpha. So we get alpha is equals to T upon L, or T is equals to alpha into L. This is our equation 2. Equation 1 is 2t is equals to n lambda. Equation 2 is T equals to alpha into L. So let us substitute equation 2 in equation 1. So we get 2 alpha L is equals to n lambda. What we have to find is L. So L equals to n lambda upon 2 alpha. At what distance we'll get the 10th dark ring? Okay, so we have to find L. So we got this formula for the length. So let us substitute the quantity. N is the order, which is a 10. Lambda is given. Lambda is 6000 angstrom, that is 6 into 10 to the power minus 5 centimeter, divided by 2 into 0.01. Alpha is 0.01 radian. Okay, so what we get is 3 into 10 to the power minus 2 centimeter. That is nothing but 0.3 mm. So we got L is 0.3 mm. So at a distance of 0.3 mm, you will get 10th dark fringe. Okay, let's go to the next sum. This is also on the wedge-shaped air film. A glass plate 10 centimeter long touch at one end and separated by a wire of 0.05 mm in diameter at the other end. So, so the length of the film is given. Length is 10 centimeter. Okay, if this is the weight of the film, the length is given here. This length is 10 centimeter. And the thickness is also given 0.05 mm, that is 0.005 centimeter. We want that in centimeter. Okay, then how many bright fringes will be observed over the 10 centimeter distance? So how many bright fringes will be observed here within this distance? In the light of wavelength 5893 angstrom, the wavelength is given 5.893 into 10 to the power minus 5 centimeter. 593 angstrom means 5.893 into 10 to the power minus 5 angstrom. And this is in reflected normally from the plate. So there is a normally reflected means R equals to 0. So as I said, if this is the wedge-shaped air film and this is the thickness and this is the length and this is the wedge angle, then we know that alpha is equals to, what is it? Wire. The diameter is given. So instead of saying T, I will say the diameter, because there is a wire given and wire has the diameter, not a thickness. So alpha is equals to D by L. This is my first equation. We also know the equation for the fringe width. Beta is equals to lambda upon 2 mu alpha. But there is a air film. So for air film, this beta is equals to lambda upon 2 alpha. Let us say this is equation 2. Then from equation 1 and 2, we get the beta is equals to lambda upon 2. Alpha is d by L. So d by L means L will go up. So beta is equals to lambda L upon 2d is the fringe width. Now we will find the fringe width first. Let us find the fringe width. So beta is equals to lambda L. Lambda is given 5.893 into 10 to the power minus 5 centimeter. Length of the film is given here 10 centimeter. 10 divided by 2 into d. D is the diameter. Diameter is also given. This is diameter actually, not a thickness or whatever. So diameter is 0.005 centimeter. So after simplifying this, what we get is 0.05893 centimeter. Okay, you get the fringe width. So width of the one fringe is this much. And here in the diagram, in this diagram, this length is 10 centimeter. And width of the one fringe is this 0.05893. So what would be the number of fringes in this length? So number of fringes in this length would be this length L divided by the fringe width. Or we can say L equals to n beta. So we have to find here n. L is 10 centimeter. Divided by fringe width is this 5893 centimeter. And what you get is 169.7. But the number of fringes cannot be 169.7. So we have to round up that. So we will round up that to 170. So n equals to 170. So in a distance of 10 centimeter, there would be 170 bright fringes or dark fringes. Whatever. There is another way to solve this problem. If you want, if you are interested. See here you got the beta, but we know that n equals to L upon beta. So L equals to n beta. Let us substitute this in this equation. So we get beta is equals to lambda into n beta divided by 2d. This beta will cancel. And what you get is n equals to 2d by lambda. By this equation also, you will get the same number, 170. So you can use any. Okay, then let us go to the next sum. And this sum is again for the wedge-shaped airplane. Let us read it. A foil is enclosed between the two glass plates at one end to form a wedge-shaped air film. When film is viewed in a light of wavelength 5460 angstrom along normal. So lambda is given. Let us write the given quantities. Given lambda is given, which is 5460 angstrom. That is 5.46 into 10 to the power minus 5 centimeter along normal. So R equals to 0 for this. 12 fringes are seen. These 12 fringes are seen in 0.4 centimeter. So length of the film is given, which is 0.4 centimeter. And in that, number of fringes are also given, that is n equals to 10. N is not order here, n is number of fringes. So in 4 centimeter, we see the 12 fringes, so we can find the fringe width. Deduce the angle of wedge. What we have to find is alpha. Okay. Thickness of foil also find. Let us write here. Find thickness of foil if plate length is 3 centimeter. So we have to find the thickness T if plate length is 3 centimeter. So we have to find thickness if L equals to 3 centimeter. Then let us read again. Also find fringe width if water is introduced in the wedge space. So we have to find again the fringe width beta if mu equals to 1.33. Okay. When the air film is replaced with the water, we have to find the fringe width. Earlier is the fringe width. This is the case. 12 fringes are seen when the film is air. So let us calculate the formula. Formula we know beta is equals to lambda upon 2 mu alpha. Okay, or alpha equals to beta upon 2 mu beta. This is the formula we're gonna use. So first, we have to find the alpha first. To find the alpha, we must know the, sorry, what I have written? Lambda. Alpha equals to lambda upon 2 mu beta. So first let us find the beta, because beta is given to us. Beta is, see, we can see in a length of 0.4 centimeter there are 12 fringes. So beta is equals to length upon n. N is number of fringes. L is 0.4 centimeter given, and in the 0.4 centimeter 12 fringes are observed. So beta is equals to 0.4 by 12, and that is equals to 3.3 into 10 to the power minus 2 centimeter. This is our beta when there is air film. So alpha is equals to lambda upon 2 mu beta. Here mu is 1. So lambda is 5.46 into 10 to the power minus 5 centimeter divided by 2 into 1, because initially there is air film, so mu is 1, into beta, which is 3.3 into 10 to the power minus 2 centimeter. So this comes around 8.27 into 10 to the power minus 4 radian. This is in radian. Okay, so that is the wedge angle. So first we got the alpha. Second, what we have to find? Thickness if the length is 3 centimeter. So second, if L equals to 3 centimeter, how much is P, thickness? Now in this, let us see, this is our wave-shaped air film, this is length here, and here is the thickness. And this angle is alpha. And alpha is small, so we can directly write alpha is equals to T upon L. Or T is equals to alpha into L. And that is T equals to alpha is, just now we got alpha is 8.27 into 10 raised to minus 4. And the length is 3 centimeter. Okay. And that comes to 2.48 into 10 raised to minus 3 centimeter. So this is the thickness. So thickness of the film is 2.48 into 10 to power minus 3 centimeter if the length is L. That is the second. And the third thing what we have to find is, we have to find beta if mu is 1.33. So third thing is, if mu is equals to 1.33, then beta equals to how much? So we know that beta is equals to lambda upon 2 mu alpha. Lambda is known, 5.46 into 10 to the power minus 5 centimeter divided by 2. Mu is 1.33 and alpha is 8.27 into 10 to power minus 4. And after simplification, we get 0.025 centimeter. That is beta. This is the beta. Okay, then let us go to the next sum. Okay, the sum number 8. Sum number 8 is about the Newton's ring. Let us read it. In Newton's ring experiment, the diameter of 4th and 12th dark rings are 0.4 centimeter and 0.7 centimeter. So what is given is diameter of the 4th ring, and that is 0.4 centimeter. Also diameter of 12th ring is given, and that is 0.7 centimeter respectively. Find diameter of the 20th ring. So what we have to find is D20. This we have to find. Now this is a dark ring, so we know the formula for the dark ring. Formula for dark ring is diameter square of nth ring is equals to 4n lambda r. So this is the formula. Now here we have to use this formula. Diameter square of n plus nth ring is given minus diameter square of nth ring is equals to 4n lambda r. So in this equation, n plus n is 12. So diameter square of the 12th ring minus diameter square of the 4th ring, n is 4. So here, see, n plus m equals to 12, n equals to 4, and so m equals to 8. So that this is equals to 4 into 8 into lambda r. Lambda and r is not given, so into lambda r. So diameter of the 12th ring is given, which is 0.7 centimeter, and square of the 0.7 centimeter, 0.7 square minus 0.4 square, that is equals to 32 lambda r. This is nothing but 0.49 minus 0.16, 32 lambda r, and this difference is 0.33 is equals to 32 lambda r. So we get lambda r is equals to 0.33 divided by 32. So this we're going to use lambda r. Then for 20th ring number, 20th dark ring, d20 square is equals to 4n lambda r equals to 4, n is the 20, and into lambda r. Lambda r is 0.33 divided by 32, and this comes around 0.825 centimeter square is d20 square. So take the square root and find the d20. So d20 is 0.91 centimeter. So diameter of 20th ring number is 0.91 centimeter. Okay, then let's go to the next sum. This is also on Newton's ring. See, Newton's rings are performed in the reflected light of wavelength 5895 angstrom. So wavelength is given 5895 angstrom, which is equals to 5.895 into 10 to the power minus 5 centimeter. Okay, with liquid between the plate and the plano-convex lens. Okay, with liquid between the plate and plano-convex lens. The diameter of the 10th ring is 0.4 centimeter. So D10 is given. D10 is 0.4 centimeter. And we don't know whether D10 is a bright or dark. That is not given. But D10 is given 0.4 centimeter. And radius of curvature of lens is 95 centimeters. So capital R is 95 centimeter. Calculate refractive index of the liquid when the ring is bright and dark. So we have to calculate mu if ring is bright, and also you have to calculate mu if ring is dark. Okay. So here we have to consider both the ring. We have to consider bright ring and we have to consider dark ring. So let us first consider bright ring. And you know that for the bright ring, diameter square of nth bright ring is equals to 2 into bracket 2n minus 1 lambda divided by mu. If it is here, then there is no mu. And what we have to calculate is mu. So mu is equals to 2 2n minus 1 into lambda divided by diameter square of the ring number. So here n is given, n is 10. Okay, n is given, n is 10, and its diameter is also given, which is 0.4. Therefore, 2 into bracket 2 into 10, n is 10, minus 1 into lambda. Lambda is 5.895. 5.895 into 10 to power minus 5 centimeter divided by diameter square of the 10th ring, and diameter is 0.4, so divided by 0.4 square. Okay, let us simplify it, and what we get is 1.329 mu. Okay, so when the ring is bright, refractive index is 1.329. Next, consider dark ring. Okay, and for nth dark ring, we have the formula diameter square of nth ring is equals to 4n lambda r divided by mu, or mu is equals to 4n lambda r divided by diameter square. Now here the n is 10, so 4 into 10, lambda is given 5.895 into 10 to power minus 5. So here I forgot to write lambda r. This is lambda r. Make the correction. This is into r, that is into 95. R is given 95. Okay. Then you get 1.329. So into 95 divided by 0.4 square. Okay, and that comes around 1.4. So mu equals to 1.4 when the ring is dark. Okay, let's go to the next one. Okay, let us see what is given in this. A Newton's ring arrangement is used with a source emitting two wavelengths, lambda 1 and lambda 2. So two wavelengths are given here. Given lambda 1 is 5893 angstrom, which is 5.893 into 10 to the power minus 5 centimeter. And lambda 2 is 4400 angstrom, that is 4.4 into 10 to power minus 5 centimeter. Okay, let us read again. A Newton's rings arrangement is used with a source emitting two wavelengths, lambda 1 and lambda 2. And it is found that the nth dark ring due to wavelength lambda 1 coincides with n plus 1th dark ring due to wavelength lambda 2. So their wavelengths are coinciding. Due to that, their dark rings are coinciding. If radius of curvature of curved surface is 95 centimeters, so R, capital R is 95 centimeters. Find the diameter of nth dark ring for wavelength lambda 1. And of course, that would be for n plus 1th dark ring for wavelength lambda 2. Okay, solution. The formula you know. For dark ring, diameter square of nth dark ring is equals to 4n lambda r. This is known. Then we will write this formula for the two wavelengths, lambda 1 and lambda 2. So dark ring due to wavelength lambda 1. For dark ring due to wavelength lambda 1, this formula would be diameter square of nth ring is equals to 4n lambda 1 r. Let us say this is equation 1. Then for this is for nth dark ring due to wavelength lambda 1. Then for n plus 1 dark ring due to wavelength lambda 2. Now this is d plus 1 wavelength. So we can write diameter square of n plus 1 ring is equals to 4 in the bracket n plus 1 into lambda 2 into r. This is equation 2. Now these two diameters are coinciding. Okay. These diameters are coinciding. They are overlapping. It means diameter square of nth ring is equals to diameter square of n plus 1 ring. They are same. So from equation 1 and 2, we can equate their right hand side. So this 4n lambda 1 r is equals to 4n plus 1 lambda 2 r. So 4n lambda 1 r is equals to 4n plus 1 lambda 2 r. So in this r cancels, this r cancels. So n lambda 1 r is equals to 4n. This 4 also cancels, sorry. 4 cancels and r cancels. This r cancels. N lambda 1 is equals to n lambda 2 plus lambda 2. So n lambda 1 minus lambda 2 is equals to lambda 2. So we get the order here n equals to lambda 2 upon lambda 1 minus lambda 2. And let us find the order directly by just substituting the values of lambda 2 and lambda 1. Lambda 1 is 5.893 into 10 to power minus 5 centimeter, and this is 4.4 into 10 to power minus 5 centimeter. So lambda 2 is 4.4 into 10 to power minus 5 centimeter. Lambda 1 is 5.893 minus 4.4 into 10 to power minus 5 centimeter. And after solving this, we get n equals to 2.95, which is close to 3. So we got the order 3. Then what we have to find is the last one, last sentence. Find the diameter of nth dark ring for lambda 1. So for the wavelength lambda 1, we have this equation: diameter square of nth ring is equals to 4n lambda 1 r. So this is 4, n we got 3, lambda 1 is 4.4 into 10 raised to minus 5 centimeter, and r is 95. And after solving this, we get 0.0672, and that is the diameter square. Taking the square root, diameter of nth ring is 0.26 centimeter, and that is the answer. Okay, let us go to the next one. Now this is on biprism. An obtuse angle of biprism is 178 degree and 41 minutes. So the theta, let us say theta is obtuse angle of the prism. And that angle is 178 degree and 40 minutes. Okay. An obtuse angle of biprism 178 degree 40 minutes, and refractive index is 1.5. The refractive index of the prism is given, that is 1.5. Then a slit is illuminated by a light situated at 0.1 meter from the biprism. So in this case, if this is the biprism and here is the source, so this distance is 0.1 meter, and let us say that is A. So A is given 0.1 meter. Then from the biprism, okay, and fringes are obtained at a distance of 1 meter from it. So here is the screen, and the distance from biprism to the screen is given, and that is 1 meter. Let us say this is a B and this is A. So B is given 1 meter. But our capital D is from source to the screen. This is capital D. So capital D is equals to, we can say, A plus B, that is 0.1 plus 1 meter. So that is nothing but 1.1 meter. So capital D is given 1.1 meter. Okay. Then from it, having fringe width of 6 into 10 to power minus 4 meter. So beta is given here. Beta is 6 into 10 to the power minus 4 meter. All are in meters. Okay, so these are the things. And what we have to find is wavelength of the light used. So we have to find wavelength. So this is source, this is biprism, and this is a screen. Okay. Solution. Let us first find alpha. We want alpha. So alpha is what? If the obtuse angle obtuse angle plus, see, this is the biprism. These two are alpha and this is theta. So obtuse angle plus twice acute angle, 2 into acute angle. That is 180 degree. So theta plus 2 alpha is equals to 180 degree. So we have to find the alpha. So alpha is equals to 180 degree minus theta divided by 2. Now theta is given here. So 180 degree minus 178 degree 40 minutes divided by 2. Okay. And I will convert this in a degree and find out. So what I got is 0.667 degree. So alpha is 0.667 degree. Then we know the formula to find d, the distance between the two virtual sources. This small d is equals to 2a in the bracket mu minus 1 into alpha. So this is the formula. Now we know the a. A is the distance between source and biprism, which is a 0.1 meter. So 2 into 0.1 meter. In the bracket mu minus 1. Mu is also given. Mu is 1.5. Okay, mu is 1.5 minus 1 into alpha. This alpha is in degree. We want this alpha in the radian. In this equation, alpha is in radian. So we have to convert this degree into radian. So 0.667 degree into pi by 180 degree. So this converted into radian. And then after solving this, pi is 3.14. After solving this, what we get is 1.164 into 10 to power minus 3 meter. The quantities are in the SI meters. So this is D, the distance between the two virtual sources, small d. What we have to find is lambda. And lambda is equals to beta into d divided by capital D. Beta is given. Beta is 6 into 10 to the power minus 4 meter. 6 into 10 to power minus 4 meter into D. We just now measured 1.164 into 10 to power minus 3. This is also in meter. And then divided by D, the distance between source and the screen. And that is 1.1 meter. So this divided by 1.1. All the quantities are in the meter. So we get the lambda in the meter. So we get 6.35 into 10 to the power minus 7 meter. And that is nothing but 6350 angstrom. So this is the wavelength. Let us solve one more problem on this biprism. No problem. Okay, there is a problem. There is one more sum. Let us see what is given. The fringes of 450 nanometer wavelength are observed through Fresnel biprism experiment. So the given wavelength is given 450 nanometer means 450 into 10 to the power minus 9 meters. Reflectional biprism. The screen is 1.5 meter away from biprism. So in this case, the B is given. The distance between the biprism and screen is 1.5 away from biprism, and fringe width is 0.25 mm. So beta is given 0.25 mm. Okay, 0.25 mm. Is it mm? Fringe width is an mm, 0.25 mm. Okay. The refractive index of the film is 1.55. How can refractive index of the film? Not a film. This cannot be the film. The refractive index of biprism. Okay, here is biprism. Refractive index of biprism is 1.55. So mu equals to 1.55. And it is at a distance of 25 centimeters from slit. So A is given. A is 25 centimeter. So 25 centimeter is 0.25 meter. Calculate obtuse angle of biprism. So how much is capital D then? Capital D is A plus B. A is 1.5 plus B is 0.25, and that is equals to 1.75 meter. So capital D is 1.75 meter. Now we have the equation lambda is equals to beta small d upon capital D, and therefore small d is equals to lambda into capital D upon beta. And also we have this equation D is equals to 2a mu minus 1 into alpha. So these both are the same. So equation 1 and equation 2. So from equation 1 and 2, we have this lambda d upon beta is equals to 2a mu minus 1 into alpha. What we have to find is alpha. So alpha is equals to lambda capital D upon beta in, let us write this way, 2a mu minus 1 into beta. So from this, we get this. Then let us substitute the values. Lambda is 450 nanometer, that is 450 into 10 to the power minus 9 meter. D is 1.75 meter divided by 2 A. A is 0.25 meter. 25 centimeter, 0.25 meter. Into bracket, mu is 1.55 minus 1 into beta. Beta is given. Beta is given is 0.25 mm. Okay, beta is 0.25 mm means 0.25 into 10 to power minus 3 meter. Okay, this is 0.25 into 10 to the power minus 3 meter. So let us multiply this into this. We get 787.5 into 10 raised to minus 9 divided by, let us multiply all this. You get 0.06875, 0.06875 into 10 to power minus 3. And that is 11454.5 into 10 raised to minus 6, which I can write this this is alpha. We are finding alpha. This we can write as 1.15, round up it, into 10 to power minus 2, and this is in radian. So we got the alpha here. What we have to find is obtuse angle. So for biprism, theta plus 2 alpha, where theta is obtuse angle, alpha is acute angle, is equals to 180 degree. So theta is equals to 180 degree minus 2 alpha. So 180 degree minus 2 into 1.15 into 10 raised to minus 2, but this is in radian, so we have to convert that into degree. So 180 degree by 5. Okay, after simplification, you get 180 degree minus 1.32 degree. And that is nothing but 178.68 degrees. And that is 178 degree 41 minutes. So this is the obtuse angle.